slides and make them the full screen here. I need 10 screens is what I need. There we go. Let's see. Okay, that should be filling the entire screen, right?
Yes.
Okay, so there we go. All right, so thanks for the invitation, Dave, and it's good to see friends old and new. I want to talk a little bit about some fundamental stuff that some of you may have seen if you took my class, like you, Kelly.
Right.
An update on some of that. So sort of a general view from 30,000 feet of speleology and the hunt for caves and their exploration outside of Earth. So as many of you know, I've been interested in writing about and involved in trying to advocate for that kind of exploration for the last 30 years or so. And finally, it's getting traction. So at the end, I'll talk a little bit about some of the mission concepts that have actually made significant headway, meaning that they have significant funding, which is the name of the game, of course. No dollars, no missions, right? So we now have a number of cave-oriented missions to different bodies that are in contention for mission status. So people, originally were very resistant to the idea of caves elsewhere in the solar system. When I first started writing about caves on Mars, we had not actually seen any. And so it was a hard sell. We were just working from first principles that when you have geological processes occurring on another body, some of those are going to be similar in some fashion to what goes on in Earth. And so it's been a long process of trying to educate ourselves, educate the planetary science and space exploration communities to the scientific potential of these kinds of bodies. So my own area of particular interest and expertise, of course, is in geomicrobiology and astrobiology, but caves offer a huge trove of data besides the biological aspects to open our eyes to the processes that have gone on many other different bodies around the solar system. We now even think some of the small bodies, some of the minor planets and some of the large, asteroids and so forth may have planet-forming processes going on in them. So this is the stripped down version. If you're a physicist, this is what you see, okay? So those of us who go into caves a lot, we know that it's more complicated than this, of course, but if you try to pursue caves to their fundamental essence, they essentially are below a significant boundary condition, which is the surface of the Earth. And so much of what we understand as humans, of course, it goes on the surface. There are a small number of us that pay attention to the subsurface. And so part of the challenge has been to have a scientific community that is used to, for the most part, thinking about surface processes, which has been the target of a lot of planetary missions for obvious reasons. It's something we can do from orbit and so forth. But this surface and subsurface boundary condition is not a hard boundary. We know that both materials and energy are transferred from above to below, and in many cases below to above in the natural course of what goes on Earth. And so it's reasonable to expect that something of that sort is also going to be the case in an extraterrestrial setting. One of the things that was big news to a lot of folks in the planetary sciences community and the geology community, besides those who have experience in caves, is that they exist in many rock types. When we first started talking about extraterrestrial caves with respect to the planet Mars, the biggest criticism that we got from a huge number of people was, well, there are no carbonates detected on Mars, so there can't be caves. Okay, so that was the level of understanding that a lot of our colleagues had at the time. And of course, we know that if there's rock, including salt and water ice, that holes can be made into it, you know, from a number of different processes. And I'm not showing any of the more technical slides tonight, but something that I've worked on for the last 15 years is really a systematic way of looking at caves that depends not on sort of folk descriptions of them, like sea caves or gypsum caves or lava tube caves, but actually looks at the fundamental chemistry and physics involved in producing holes in rock. And so that's something that I've published on a number of different times. So opening up our eyes in the planetary realm to the fact that there are ways to make holes in lots of different solid materials. One of the things, of course, that's the most important for a lot of the exploration that we're contemplating is really the contents of the cave. And of course, I love this picture of poor trash compactor cave in Tennessee because this is a classic example of humans using caves as repositories of trash and dead cows and all stuff like that. But the good thing about caves is that they actually protect this kind of material. So from the point of view of natural processes, they're wonderful repositories. And so we expect to be able to find sedimentary materials that are blown in from the outside into caves that have openings, not all do. We expect that caves with openings and without openings on other bodies are going to have very different gas compositions, and that may help not only in understanding the processes in the cave itself, but also deeper subsurface processes. So for example, one of our early, now classic, I'm told, papers on this in 1992, we published a paper suggesting that you could sustain a subsurface biosphere, a microbial biosphere on Mars from geogases that were energy producing materials for microbes on Earth. And so caves could act as traps for that. Certainly we know that on Earth we have water ice frozen in caves. We suspect that that's the case at least on Mars and probably also on the Moon. And we also understand that there are complex mineral deposits that occur in subsurface terrains. Obviously, there's the biology end of it, all the way from organisms that are alive through those that are preserved in some fashion, all the way to very much more subtle signatures of life, which we call biosignatures. And this can be anything from fossils to really subtle biopatterns or even geochemical and biochemical evidence preserved within the rocky material. So all of those are of interest to us. The role of caves as amazing preservation environments on Earth is something that we use as a frequent talking point. Some of you have probably seen some of these images before. This comes from the work of myself and sort of our greater research team, Diana Northup at the University of New Mexico, Mike Spildy at the University of New Mexico. We've all been working together for in excess of 25 years on this stuff, and lots of students and other colleagues around the world. And so what we have discerned is that even though microorganisms are very minute individually, in their aggregate, they produce major changes in geological processes, and those geological processes are detectable. So for example, the red material, famous gorilla poop, corrosion residue in Lechuguilla Cave, and in fact, other caves around the world, clearly a microbial breakdown product of the rock. And so this is a very indicative biosignature. Snowy River in Fort Stanton Cave below, also here in New Mexico, that many of us have done quite a bit of work on. It's famous, of course, for the beautiful Snowy River calcite deposit, but one of our interests are those black streaks that you can see beyond in the passageway on the walls and on the ceiling, and these are manganese minerals that, that have been transformed by the action of microorganisms. The lower copper speleothem in Hawaii is a gooey stalactite-like object that is composed of copper minerals that have been acted upon by microorganisms. And if you look at an electron micrograph of that material, you can see it's absolutely packed with life forms. Even the residuum that you can see in that piece of cave bacon, where mobilization of iron by microbial activities and plus the presence of organic material that has been used by microorganisms or is available for microorganisms can also color speleothems that are not themselves a product of microbial activity. So these little tiny guys leave their footprints in many ways. In some of the richer, moister caves around the world, of course, we see living microorganisms that actually look like microbes, gooey material and gloppy material and microbial mats and slime molds and things like that. But I want to draw your attention to the upper left image on your screen labeled rainbow quilts. And this is all within one of the Hawaiian lava tubes that we have studied over the years. And all of that coloration looks like it's mineral deposits, but all of it involves microbial activity. So when you look at it, it doesn't look gooey like some of these other pictures, and yet it's as valid a biosignature as others. And then the other image I want to particularly point out, excuse me, is in the lower right-hand corner, the powdery salts in the Mojave Desert lava tube cave. And that material is a salt known as phenardite. But that also is actually super dry, and yet it's packed with microorganisms. So some of these biosignatures are hard to determine whether or not they're biosignatures just by looking. And it takes a lot of additional work to actually work through whether they are or not. Here's a potpourri of images that show these biosignatures at many scales, some of my favorite ones. So one of our French colleagues up in the upper left-hand corner is looking at a big patch of blue material. This is the same kind of copper transformation that I showed in the last slide in that little tiny stalactite. This is also a copper transformation. This happens to be in a mine cave in Sardinia. Of course, in the middle upper part there, you can see snotites. These are famous because we love the name of them, and those are occurring in very hydrogen sulfide rich caves. These particular examples, of course, were the first ones that we really identified. Jim Pizarowicz and several other people sort of discovered this in the mid 1990s in Cueva de Villaluz in Tabasco in Mexico. The red material that you see there forming a stalagmite-like material, that is entirely composed of tulip-shaped microorganisms that you can see on the very right-hand side. You can see an electron micrograph labeled red tulip microbial iron stalagmites. So those microorganisms are packed together with iron oxides that they have precipitated around themselves and forming those formations. I could go on and on about this. I don't want to do that, but I just want to give you a visual spectrum of all of the different ways that microbes can produce materials that are distinctive. And we've been documenting these over the last several decades. And now there are other groups that are doing this as well. And so hopefully the community of people working on this is gradually growing. We're still a very small, scientific community, really, when you look at many other areas of science, but nevertheless, definitely making strides in understanding these kinds of materials and understanding that they are actually affected by microbial processes. Some of the extremes that we have looked at you know, make great TV and all that. But the reason that we're studying them, of course, is because we're trying to look for the envelope of conditions within which Earth life can grow and tolerate those conditions, and, you know, try to apply the lessons learned from that to the extraterrestrial environments that we may be able to explore. So Cueva de Villaluz on the upper left, this is work that started in the late 1990s. Louise Hose led an expedition in late 1998. That was my first exposure to this cave, and we've studied it on and off ever since. We've had several grad students do their dissertations on different aspects of the chemistry and the biology in this cave. And it's notable because sulfur is a very common material in the solar system. There are many bodies within our solar system that have significant amount of sulfur and sulfur-rich conditions, Mars being one of them. And so the potential for sulfur to be associated with biological processes is quite high. Some people have suggested that the metabolism of sulfur was actually the first metabolism in the origins of life, even on this planet, when it was an anaerobic environment, and gases were the materials that early life and proto-life and pre-life chemical reactions may have had to work with. Of course, because there are icy moons around our gas giants, we're very interested in cold environments. And so the upper right-hand image shows some work that's been going on in Mount Rainier. There are fumarolic ice caves that are produced in ice masses from the heat generated by these fumaroles, because of course Mount Rainier is a very big volcanic mountain, and it still has considerable thermal interior activity. It's considered an active volcano still. And so these kinds of caves can be of interest when we're looking at icy bodies. The Nika caves have been quite famous and covered a lot by the by radio, television, magazines, podcasts, and all of that. These gigantic crystals, which I'm sure you've probably seen. The interesting part of it to us was not just the crystals are magnificent, it's an amazing environment, but it's also a very high temperature environment. And so that's appropriate to some planetary conditions. The other interesting part, of course, was that there are actually live microorganisms and sequenceable, understandable DNA preserved in microcrystals within these giant crystals, or micro inclusions, I should say, micro holes. And we were able to get those out of there. And so that, besides the hot temperatures, the other issue there that's of interest is the fact that organisms can survive in inactive states for perhaps tens of thousands of years. Other claims have been as long as you know, hundreds of millions of years, but that's very hard to demonstrate. There, in the 1990s, there was several papers written about the whip site and microorganisms recovered from holes in the whip salts. And so that's, of course, obviously interesting to us in New Mexico because that's right here in our state. And then the cave decoration in Snowy River in Fort Stanton Cave that's garnered a lot of attention that I showed you the other picture, where we're interested in the manganese organisms that are making black streaks on the wall. But the other aspect of it is that coring down through the beautiful white crystalline material, we can actually see fossil microorganisms, and we've recovered plant biominerals that have come into the cave in past epochs. They're called phytoliths, meaning plant stone. And those can give us an indication of the surface environment in past geological times when those deposits have been made. So you can look backward in time, as well as looking at a static state within the cave. So all of this, you know, buzzing around in my head for many years, I finally wrote it up into kind of a scheme for thinking about planets and thinking about our own solar system, which is what we know best. the type of biosphere that we have here on Earth has what's known as a well-mixed critical zone. So the critical zone is a term that's used to mean all of the narrow part of Earth's surface, a little bit above and a little bit below, that is really where all of the life on Earth takes place. So the lower troposphere, or the troposphere in the atmosphere, and the lower stratosphere, and then down to the oceans and perhaps 5 to 10 kilometers into the crust. These are this is the very thin zone on our planet in which all of life occurs. And so this is a signature of our planet, that we have a very robust critical zone, and it's very well mixed in terms of materials and energy flow. And it also is top-down driven. So it's driven by light energy from the sun. But we know from working in caves that there is another aspect of life on Earth. And this is more akin to what we're likely to see on other planets in our own solar system. So I've been calling these hypothetical biospheres that we have not yet detected type 2. So when you look at Mars, or you look at Europa or Enceladus or Titan, you don't see visible evidence on the surface like we do on Earth. If you look at Earth, you can even see the spectral signature for the protein chlorophyll, right, that dominates the system. But there's no hints of that on these other bodies in our solar system. So if they contain life, then that life is cryptic. It is subsurface life. So in Mars, if a biosphere still exists, it's underground. And so that's one hypothesis that we've been working on for many years, as I've mentioned before. The other aspect of it is, with these icy moons, people are calling them ocean worlds, but I think that that's a misnomer, because they do not have open oceans. What they have is roofed systems where the entire body is encased in water ice bedrock, and it has an interior fluid. And so that makes it more like a cave to me, like a planet-sized cave, in terms of how you think about it, how you think about the materials and energy flow, and also just operationally, how you think about how you get into it. So what do we currently know about extraterrestrial caves? Well, we have a little bit of knowledge, and it's growing all the time. And then we have a lot of speculation. But then, of course, that's, you know, how planetary science leaps forward. So we certainly know from original studies early on in the last decade, in the mid part of the decade, Cushing and Tim Titus and other folks at USGS and Flagstaff identified a number of large pits on Mars. We had already identified a number of lava tube structures. Harayama et al. Finally in 2009 identified pits on the moon. And that was because we began to send missions back to the moon. The Japanese space agency JAXA sent lunar missions, and NASA, we have sent several lunar missions. And so the first suggestion that there would be lava tubes on the moon was actually made by Ron Greeley when he was a very young man. He passed away a few years ago now. When he was a very young man during the Apollo era. In 1969, they published a paper. So you can see it took 40 years between the suggestion that there would be actual lava tubes and pits on the moon before visual evidence was actually obtained. But you can reason from first principles. And so my starting point was that any planet with a surface will develop cracks. There are the potential for internal tectonics, even on planets that don't have plate tectonics. There are, you know, internal moonquakes, there are internal Mars quakes, there are undoubtedly internal perturbations within other planetary bodies. And then there's, of course, external factors. So we know that things are banging around in the solar system, and we certainly experience that on Earth on a fairly regular basis, and so have all the other planetary bodies. And so there are ways of making, a number of ways of making cracks. The cracks themselves, of course, can become potential habitat, and they certainly have a different internal environment than the surfaces of their bodies. There are also potential to be widened by fluids, other tectonic forces, even aeolian forces on bodies that have planetary atmospheres. And some very exotic examples have come to light since I made this slide, the original version of the slide many, many years ago. Certainly the giant moon around Saturn, Titan, is of huge interest because it looks so Earth-like when you look at it through radar images from the Cassini mission that ended a couple of years ago. But it's entirely made out of water, water ice as the bedrock, with organic deposits on top of it. And the liquids are all methane, liquid methane, and other liquid alkanes. And so we think that Titan has significant potential for actually being a true karstic environment. There have been a number of folks to actually publish on that. I've been involved in some of that work peripherally. So very exotic settings, and yet we're still looking at some of the same fundamental principles that we have derived from speleological studies here on Earth. You can get way far out in your thinking, which I enjoy. And so we've explored the idea of caves from mechanisms that we don't see on Earth. One of my favorite fantasies is caves on comets that are produced by the heating of the comet as it goes near to the sun in its perihelion passage every time it goes around. And that mobilizes a lot of the ices. And so you would expect that cavities would be formed in these bodies. And it'll be interesting to see as we continue to explore those if that's going to be the case. So the current status really is that we now have pits of all different kinds. We have lava tubes on the moon and Mars. We even have pits on Mercury. So the Mercury Messenger mission, I have a cat draping on my shoulder here. He's gradually dripping down, thus proving that cats are actually fluid. I don't know if you've seen that physics paper, but it was published a couple of years ago. It was a really good paper. Anyway, aside from my fluid cat, this, this image of Mercury shows a crater, and there is a big pit in the bottom of the crater. And so there are even caves of some sort, even on Mercury. Venus, that you can see in the upper right-hand corner, that is a very weird planet. I'm on a Venus flagship mission concept study project right now to try to do a lander, although certainly not a cave lander. We barely can even get to the surface of Venus at this point, but Venus appears to have volcanic caves. Even Io, the tremendously volcanically active moon around Jupiter, most active volcanic body in the solar system with extremely sulfur-rich lavas. It has tubes, it has pits. And so this phenomenon, certainly volcanically, is pretty widely spread throughout bodies in our solar system. One of the challenges that we have, of course, is trying to do speleology by remote observations. And a lot of the work that's been done, of course, has been from orbiters. And so it's very hard to interpret some of these features. I want to draw your attention to the right-hand image particularly. You can see the arrow pointing to a dot. That appears to be a cavity. This is not a volcanic structure. This appears to be a glacial esker that has been pushed up in past epochs on Mars when there may have been the presence of solid ice glaciers on the surface. And this appears to be some sort of subglacial channel from the past, from Mars's distant past. We've tried to have special imaging done of this, and so far have not been able to do it. This original image was from the Mars Observer camera from previous epoch of missions, and we've tried to have it reproduced by the current high resolution imager HiRISE and have not yet been successful, but we're dying to get a look at this because this would be something like maybe a Sophosian cave where particles have been removed by fluid over time in the past. I just want to talk a little bit more about some work that should be of interest to you folks, because you're down in the area where we did this. This was work by former graduate students of mine, Kevin Stafford and Laura Rosales Lagarde. And what we tried to do was look at the Castile evaporite karst potential on the gypsum plain and compare remote analysis methodologies. So you can see the cumulative karst features grid down in the lower right-hand side. That's digital elevation model, digital ortho quad, DRG, and then field mapping. And what we were trying to do was look at if there was a proportionality between these remote methods of sensing and what the actual karst richness was on the surface. And so you can see that you can actually probably develop a way of looking at a particular type of remote sensing and then estimating how much greater the actual density of karst features would be. And I raise this because there are many evaporite mineral deposits on Mars, and they have the potential for having developed dissolutional karstic terrains and karstic features over time. Certainly, we have many physical analogs here. The upper left-hand image is a high-rise image showing the Tartarus Cullis. It's a lava area of Mars, and there is an open lava rill with a bridge. We see these features very similarly on Earth. The lower right is from an area that we've studied a lot because it's very close, of course, to us in the Albuquerque area at the El Malpais National Monument. And you can see that the formation of these look very familiar. This is a lava bridge. And so the thing to point out, though, is that the scale of a lot of these features on Mars and the Moon are much larger than matching features on Earth. And this may be attributable to the lower gravitational constant on these bodies. They're much smaller, but there may be other subtleties in terms of the actual chemistry of the lava flows. And so there's much to be determined to try to compare this difference in size. To some extent, it may have originally been because the larger features are much easier to see on remote, from remote observations. But as we see more and more of these features and more of them are identified, it does seem to be a real factor that these features are bigger on Mars and the Moon. So the current status in terms of how many identified cave features on Mars, it's well in excess of 2,000 now, 2,000 trending to 3,000. So that's a heck of a lot of terrain. And a lot of that has been sort of incidentally discovered. In fact, we also, had a lot of citizen science participation in this. The high-rise images are available online. The University of Arizona, or the, University of Arizona maintains the site on this. So anybody can go on and look to their heart's content over just thousands and thousands of images. And so there are probably a lot more cave features that haven't been explored, but our tally is now growing very large. There is a person who is cataloging a lot of the lunar cave features, and he's at Arizona State University, and the tally now is well over 300 of these features on the Moon. And this is important because we appear to be going back to the Moon big time, or at least that's the current political mood of the current administration. And so we are responding to that in NASA very aggressively. So Moon lava tube features and pit crater features are high on our list right now. I just want to show the dimensions of a typical Martian pit cave entrance. We don't know at this point whether there are leads coming off from below. We sure hope that there are, but even if there aren't, there are you know, such tantalizing features. You just want to drive up to this thing in your pickup truck and rig off it, right? And rappel down in there and see what it is going on. And so we're trying to do that with robot concepts. If you compare that to an American football field, you can see that it's a pretty damn big hole in the ground. I have a version of this slide that I use for Europeans, which shows a soccer field. So I can speak many different languages. You know, we of course are looking for Earth analogs. And so one of the things that we came across rambling around the West, of course, is the West Desert sinkhole. And so I superimpose the outline of the West Desert sinkhole. You can see it's minuscule, really, compared to the size of this pit on Mars. Here's a view of the West Desert sinkhole. It's 22 meters in diameter. It's probably about 40 to 50 meters deep. And I have pointed this out to a number of people. And in fact, the Carnegie University in Pittsburgh, their robotics team is now using this as one of their test sites because it gives a little bit of a flavor, even though it's not a volcanic feature like the ones that we've identified on Mars, but it might be similar to that Esker hole feature that I showed earlier. This particular lava collapse feature in the Galapagos Islands, even though it's covered by weird green stuff that I think they call plants on Earth, this is approximating a little bit closer the incredible size of these regularly large hits on Mars. This is an 80 diameter collapse feature, so 20 meters smaller than the pit that I just showed you on Mars. If you look real hard at the image, you can see tiny people. I can barely see them on my screen. Tiny people across the way. This is an interesting feature to us because we took this shot a few years ago when the Volcanospeleological Congress happened there in the Galapagos. And this is interesting because this is a eruptive center that has collapsed, but there are all sorts of tubes leading off the bottom. So this cave goes in a lot of different directions. And so we're hoping that that's going to be the case for the Mars situation and the Moon situation, but we don't have any direct detection of that. One of the things that is very interesting scientifically and also in terms of human exploration, and that is the potential of ices within caves. We certainly well know that we have permanent ices within caves on Earth in many different places. There's a congress that happens, what is it, every 3 years, George? I forgot, something like that. And so it's a very great interest on Earth, but it's also a great interest on whether or not there would be habitat potential in Mars caves for the persistence of such ices. And so there's a modeling study that was done in 2010. There's some more sophisticated modeling that's just being done now after a hiatus of almost a decade. And what it looks like is that you have a number of tens of thousands of years of stability of a 1 meter of ice in caves. And that if you alter the circumstances of how you model, you can push that up into the 100,000 year stability range. And we know that Mars tilts, right? So right now it's tilted with respect to its axis about the same tilt that we have here on Earth. But over 120,000 year cycles, it tilts much more and goes from almost zero tilt to maybe 60 degrees. And so the climate variation over time is much greater on Mars. And so we're actually in Mars winter now. And when in a few tens of thousands of years, we start coming into Martian spring, that may re-energize the hydrological cycle on Mars. So that fits in with, are these habitats, could organisms survive for good periods of time? And if not of astrobiological interest, there's the potential for those ices to retain the climate signal on Mars. So there's a lot of different science to be gained. This is just trying to hammer home that point that icy satellites are not really ocean worlds, but these planet-sized aqueous caves. And here's a diagram through one of these bodies. We normally think of the interior there as the whole planet or moon has this watery, maybe slushy, we don't really know, probably very salty, oceanic interior. So with a rocky core and then this very, very thick layer of water and then a very thick crust of ice. And the thicknesses of all these things have been the subject of extensive modeling for all of the bodies of interest. But there's many other potentials. So I imagine that most of you are familiar with the so-called pressure melt lens lakes in the Antarctic ice mass, like Lake Vostok is the most famous. And they call it a lake, but you know, we all know that it's a cave, right? It's a cave in water ice and it's filled with fluid. And so that pressure melting, rather than just the thermal melting, is definitely possible in these icy crusts. We certainly know that there are surface towers that have been proposed both in the poles on Mars, but also for these icy bodies. There could be fracture cavities like glaciers that have cavities within them, and also plumes associated with the kinds of plumes that we see around Mount Erebus in Antarctica. And old data from the Voyager missions that went in close proximity to Enceladus, the most likely candidate for an ocean interior around Jupiter, have shown that they see records of plumes. And so we now think, after many years of not understanding that in the data, that there are actually plumes of material coming out of Europa. We certainly know from the Cassini mission that there are vast, currently active, beautiful plumes on Enceladus that we see now. And Enceladus, of course, is around Saturn. So it may be that these kinds of plumes are quite common. Who knows? We certainly see them here on Earth. And so I show here some of these Mount Erebus fumarole towers. They typically are over ice caves. So talking about those fumarolic ice caves, I show another picture of the Mount Rainier fumarolic ice caves here. But the potential for those to be indicated on the surface by these towers could be a clue that we don't yet have the resolution to look at. We do have a new mission that is going to go to Titan. And there is lots of wrangling over whether or not we're going to have another mission go to Europa. We have one mission that's on the books that's going to Europa called the Europa Clipper. And that's going to go dip through and try to get atmospheric material being given off. But the Europa Lander mission is on hold. And, you know, we are always at the whim of the political winds. And so that mission has been worked on a lot. It will eventually happen. So the idea is to actually land on Europa, and I'm in there swinging to try to get it to land in places where there may be these kinds of surface indicators. Turning back to the Mars case, let's see how much time, I've got a few more minutes, I'll wind up. We have long suggested that not only these open lava tube formations might be of interest, but perhaps even more of interest would be the sealed, collapsed remnants or end parts of some of these tube features, where during Mars's warm, wet period many billions of years ago, when Mars had an active hydrological cycle with rain and all kinds of weather and so forth, and it may have had life on the surface or near the surface, that kind of material could be preserved best within collapsed sections of lava tubes from that period. That if we were going to do a drilling mission, many drilling missions, of course, have been proposed. We have drilling capabilities, very shallow drilling capabilities on the missions that we now have there. And on the one that is supposed to launch later this year. We're still on track for Mars 2020 to launch in July. It has a limited drilling capability. Also, ExoMars from the European Space Agency has also got about a 1 to 2 meter drilling capability. They're going to do it just in a delta formation, which will be interesting. But what we'd like to see, of course, is the ability to do this drilling actually into these volcanic features that may contain all sorts of goodies on the inside. Pointing out another tantalizing feature, this is in non-volcanic sedimentary terrain on Mars. It was observed by several colleagues at the SETI Institute a number of years ago. And it's a big, giant gash. And you can see that there's sunlight on the back wall. This is an enormous feature, 300 meters in the long dimension, about 100 meters across in the widest dimension. And this is in sedimentary material. It is possible that it is in a terrain where there are ancient floating glaciers. And you can see in the context image on the right where the gash is, and you can see those large plates of material that are, of course, now covered in debris. But the suggestion has been written about in a number of papers that this is probably ancient glacial terrain which deposited and trapped a lot of particulate material, and then, of course, the ice is sublimated away. So there's vast potential for these. One of the scenarios that we published 15 years ago almost now is the idea that you could have, even in a modern Mars or recent Mars, you could have the mobilization of frozen groundwater. So we know that there is ice widely spread in the Mars environment, and we know that heating of that water upon impact from an impactor could potentially do 2 different cave facilitating mechanisms at the same time. It could greatly fracture the bedrock, and then it could mobilize fluid. And mobilizing fluid in a sulfur-rich environment, we may be able to produce acidic conditions and get sort of catastrophic cave formation processes going on episodically. This is something that has been explored in the Earth case, but not in terms of making caves, but in terms of making transient habitats. And this has been in the polar regions. So there's been work on this in the Arctic, in Houghton Crater, which is very far north. It's on Devon Island in the high Arctic, off the coast of Canada. And so that mechanism, who knows? Maybe there are relic systems that have delved into the subsurface and done that. So just to wind up here with a couple of tantalizing missions that are coming along nicely. The space agencies, of course, we know that the fundamental science costs a lot, excuse me, but the staggering amounts of engineering is really what constrains missions. And so the concepts comparatively are easy compared to actually running the engineering to figure out what is feasible. And so concept doesn't become real until it's undergone what's known as a phase A study. These are significant studies where everything is engineered at least at a high level, but it also, tries to look at instruments that you would fly, mechanisms that you could actually use in order to access whatever the site is that you're interested in. So the ones that have undergone that are several, and a number of these were presented along with the fundamental science and exploration capabilities at the recent meeting in February. It was in San Antonio at the Southwest Research Institute there. There are a number of cavers and cave-interested people who actually are scientists and engineers at SWERI. And so it was a great place to hold the third one. The history of this conference starts with a small meeting that I organized in 2007 just looking at the caves of El Malpai and from the extraterrestrial point of view. And so we staged that in 2007. And then at NICRI, we organized the first International Planetary Caves Conference a few years later. I think it was 2011. And then the second one was organized by the folks who have done a lot of the work on the Mars caves a few years later at Flagstaff at the Lowell Observatory. And then the third one has just taken place. And so tremendous amount of work has been done, and a tremendous number of people have joined the community of interested people who are actively working on this whole issue. One of the notable projects I illustrate here, this is a superposition of the robotic device that Red Whitaker and his colleagues at Carnegie University in Pittsburgh have been working on. Red has been working on extraterrestrial robotic stuff for the last 10 or 12 years, and I've been involved with him on several different proposals and so forth. I've also worked now with one of his former grad students who's actually at NASA Ames, where I work on other projects, but this one has been funded at a fairly high level. So this has achieved a phase 3 study. And so this is a 3-year study, several $1 million to actually push this concept. So they are building robots, they are running them through tunnels, they are running them through caves, they're doing a lot of mapping with LiDAR, so small LiDAR units mounted on the robotic devices. And so this concept for accessing over these treacherous lips on the moon is going to be at a much higher technology readiness level. And if you're not familiar with this, acronym, we live by this at NASA. It's TRL, which is technology readiness level. And so, nothing makes it into the mission category until it's reached a fairly high technology readiness level. And so this project will help to push this whole concept of being able to get into moon caves to a technology readiness level that ought to make it available to really be pushed then into a type of a mission slot. The other exciting moon diver mission that is coming out of the Jet Propulsion Lab, a young geologist, Laura Kerber, who is at the Jet Propulsion Lab, showed up at the second International Mars Caves, or Planetary Caves meeting. And from that, developed this concept of a rappelling robotic device. So you can see several versions of the Axle robot. It's now in probably its 5th generation of development, working on how to rappel down one of these lunar pits. They've picked the pit that they're interested in, which is the one that I show here. It's about the same size as the Martian example that I showed you. And the point of this, of course, is not astrobiology. It is the lunar history of the moon's geology. So we know that the moon has gone through many different episodes, and it's gone through periods where it had, global lava deposition episodes, the giant mare, of course, are part of that. But there are many other geological episodes that have occurred on the moon. And so Laura's concept is to be able to map the detailed stratigraphy of that as the Axle robot, as the moon diver goes down into the pit. And so they've done a lot of field work on prototypes of this. They were in contention for going to the next phase. These are very, very competitive. They got beaten out and just found that out in February. But of course, that doesn't mean the end of the road. They're going to continue on with this and recompete it at the next opportunity. They lost out, I'm embarrassed to say, to several other missions that are wonderful that I happen to be part of. So I was really conflicted. But I know that the moon diver team is going to keep in there slugging. So Laura has become a very valuable member along with her team of this sort of budding extraterrestrial exploration group. And so now I'm in my backup slides, and I think we're about out of time. So let me just end there. Thanks everybody for showing up.
Penny?
Yeah.
It's Larry Pardue.
Hi.
I think I heard you give a presentation several years ago when you talked about bots to investigate caves in Mars. Is that still actively contemplated?
Yes and no. So the good news is that we pushed that much further than we did when I gave that briefing. I think that was at the Winter Technical, wasn't it, Larry? Probably.
I'm not sure.
Yeah, I think it was sometime in the past. So we went quite a lot farther with that project. One of our former grad students, Aaron Curtis, went to the Jet Propulsion Lab to do his postdoc. Now he's been hired on permanently. And so he was working on a version of the lemur robot, which was the one with the spines, the microspines for clinging onto rock. That project went very far. Unfortunately, the principal investigator of that has been lured away to go work at, is it Google? I think Google, in terms of, you know, robotic delivery of services and stuff, because they probably pay twice as much as NASA does. So that has now passed into the hands of another person who has not yet really taken the reins, so we're kind of in limbo. But at the same time, another JPL person, a guy named Ali Aga, we've got another robotic concept that has been competed in the DARPA challenge, the DARPA robotic challenge, which was to go through a tunnel autonomously. So they came in second with that competition. We now have another proposal to go on further, and they're competing again this year, and the DARPA challenge is through a real cave. So, so there's a yes part and a no part. I'm hoping that lemur will rise again, because, you know, we spent many millions of dollars on this thing and it has a lot of potential. So hopefully JPL will continue to push that forward. But I think the young man who's taken over, you know, is up to here and trying to learn the job. So we're kind of quiescent. Another project that I haven't mentioned that was not even on the books at the time that I gave that previous talk, the principal investigator is a woman named Jen Blank at NASA Ames, and Diana Northup is part of that team. And they are working with a more primitive robot platform, but trying to figure out what biosignatures you can detect. And they're working in Lava Beds National Monument in California. So I helped field season before last. Mike Spilly and I were up there helping. So that project was funded for 3 years. I think it ends, and there'll be more papers coming out from that work. So there's quite a bit of work that's going on with the robotic end of things. The problem with converting that into missions is risk managers. So, you know, we've flown lots of things that roam around on planetary surfaces on wheels. So they keep wanting to use wheels because it has heritage. But of course, from the point of view of trying to get into, you know, subsurface terrain, wheels are largely useless. They're fine to get you to the edge of a cave, but then you have to have some other way to get in. And so trying to come out of the valley of death, as it's called, which is the technology readiness levels where you've sort of proven the concept, but you haven't been able to fly it in any tech demo context. That's very hard to cross that chasm. And so a lot of these really creative robotic concepts have not yet been flown. And so one of the things that I'm pushing hard to do is try to see if we can get, you know, serious tech demo flights, particularly with supposedly a lot more lunar missions coming up than we've had in a very long time. And so that we can test that autonomy and those novel modes of moving around and so forth that we need. So, it's a mixed picture right now. It's very hard to do.
Thank you.
Sure.
Any other questions from anyone? Dr. Boston, you mentioned some microbial studies on thenardite. Do you know about the seasonal thenardite deposits we have in Carlsbad Caverns?
I do. I've never seen them.
I can send you some pictures. That
would be great.
They only grow in the winter time whenever the air is dry enough down there.
Right, right. We have thenardite in the back of Four Windows Cave at El Malpai. And it's an interesting story, really. We didn't think to really look at the mineralogy of that there. And this was many years ago. It was one of my colleagues at New Mexico Tech, Tom Kieft, who's a microbiologist, and he had a master's student, and she wanted to do some cave stuff. So we took her, into Four Windows, and she sampled a bunch of the material, and then she did the genetic analysis. And what she found was that the white stuff at the back of the cave had a really different microbiota. And so we actually discovered that the mineralogy was different because we went and then looked at the material for its mineralogical composition. So this was a rare case where the microbiology actually led the mineralogy. Usually it's the reverse, And so then when we saw that thenardite in the lava tubes at Pisgah lava field in California, we immediately sampled it because we had, seen that this material was of biological interest. So it was kind of a serendipitous experience. But I would love to see those pictures.
Any other questions or comments from anyone?
I just appreciate you doing this for us, Penny. It was really great.
Oh, happy to do it, Kelly. Yeah. Maybe I'll join you as you do this remotely while you're doing it remotely.
That would be awesome.
I have to tell you that today I led the NASA Knitting Club on an online knitting club session. So,
oh my goodness. You've been from one extreme to the other today.
Absolutely. We were all there knitting and talking about knitting and showing our projects and stuff. So we're trying to keep it together as a community,
Well,
you didn't have to wear a face mask.
That's right. That's right. I don't want to knit in a face mask.
That's a close-knit community.
Oh, God.
I can't take the credit. Melissa just said that one off screen.
Ah, okay.
That's Melissa.
Melissa's the brains of the operation, I see.
Well, you're of course welcome to join us for the remainder of the meeting if you care to.
Sure.
You're obligated to. Emily, did you want to take over from here?
Yeah, thanks a lot. Definitely took a lot of notes. I've talked about you on some of my tours, so it was nice to learn a little bit more about what you're up to. Thank you.
Sure.
Yeah.
Glad it was helpful.
Yes. All right. So let me figure out.
Sharing. Good. Okay. I'm off.
Let's see. All right. All right. Can you guys see my screen?
Yeah.
All right. So Dr. Penny Boston, thank you so much for coming in today. So we're just going to go over our standard business agenda, trip reports. I've had some people email me just a few pictures of what they've been up to in the last month. I don't think there's going to be any trips coming up in the future right now, and then we'll go through our basic meeting agenda. So trip reports, Angelina, this first page is all about what you've been up to. Did you want to share a little bit about what you've been up to in Cottonwood Lake, and you took some visitors in Christmas Tree Cave?
Hi, everyone. Yeah, so I've had a chance to do a little bit of caving last couple of months. Maybe the thing I most want to talk about is the Cottonwood Cave Formation Repair Project. That picture there in the center of me and Ellen was taken by Ellen in Cottonwood Cave in a second parallel. The trip was led by Mr. Mike Manser from Sandia Grotto. As a lot of you know, he presented presented at the grotto in January. He's been working in the second parallel since at least August. And on that trip, it was me, Ellen, and him, and we repaired the 100th formation, like you can see there in the top left. The 100th formation was repaired, so huge milestone. Unfortunately for now, not surprisingly, the project there in Cottonwood has been put off until further notice, until things settle back down. But aside from that, I also wanted to mention Colin and I don't think Colin's on the meeting, I haven't seen him, but Colin and I have been tasked, supervised by Ellen, we've been tasked to deploy radon monitors in Carlsbad Caverns recreational backcountry caves. So we've been doing a lot of caving for that. So that's a picture of lake. He also went out to Christmas Tree with a few people. We've gone to Helen's. We've also gone out to Goat and Chimney, and then soon we'll go out to Corkscrew and Wen. So I think the only caving really happening is work caving, and we'll go to Corkscrew and Wen in the coming days.
Awesome, thank you. And I think I have a slide in here. So more radon monitoring and in Chimney. We'll go back to the talcum passage in a second. You did some graffiti removal in Goat Cave?
Yeah, so I went out to go last Sunday of March, went out with Andy and Anthony, one of the new guides out at Cave. So three of us went out. That picture was taken by Anthony, that bottom left picture on your screen, that was taken by Anthony. You can see the massive entrance of Goat Cave, and that's me there for scale hiking down. And yeah, we found some graffiti. It actually wasn't the first time we saw it. We had seen that graffiti when we went to the cave last year. In March of 2019, but somebody wrote, looks like in charcoal, they wrote, and it was from 2018, so we were just able to rub it off with our gloves. So it was very superficial. We were able to rub it off, and of course we let Ellen know in her trip report we had done that, and Ellen seemed to have appreciated it, so I'm glad she wasn't upset.
Awesome, thank you. And you had some visitors that you took into Christmas Tree Cave from Tennessee?
Yeah, more or less there were visitors. So they're actually cavers from back east. It was Terry Sherman. He's the chair at Ozark Highlands Grotto out of Missouri, and Cheryl Pratt from Grotto in eastern Tennessee. I can't quite remember now. They were in town for about a week, and unfortunately they had a bunch of people cancel on them. They pretty much were not able to go on trips unless local cavers went out with them. And I had a chance to go with them, as well as Colin. I know Colin went to Chimney with them, I believe. And on March 17th, I went out with them to Christmas Tree Cave. I think that was my second time in there, and that was a lot of fun. It's a real pretty cave, so glad I had a chance to see it again.
Awesome, thank you.
Yeah,
and Dave, you were part of something pretty epic in the Talcum Passage recently. Do you want to share with us what you did?
Yeah. You know, with work, small groups are still working of no more than four-ish people, and maintaining social distancing, of course, which wasn't too hard in the Talcum Passage because it's a pretty big passage, as you can see with those gypsum blocks there. There was an old light up there. Dan Pollack was with me up in the passage. He took the photo that you see on the right. And that light was a tube light about 4 feet long, a foot wide. Ellen was overseeing the project, but it was in the upper Talcum Passage. And to my knowledge, only 4 people have been up there in about the past 20 years. And it overlooks lower caves, so we're able to lower the light down. It was an old light that's no longer in use. And we used
That's a sad thing, because that was about the coolest light in the cave, I think.
Yeah, I was looking around up there, and I thought it would give some neat perspective if this area was lit up, because you have no idea how big that tunnel is looking over
It
across.
was awesome.
Yeah. who knows, maybe someday again. But the certainly the light that was up there was quite old, and so it had to be removed. And so
Tom Bemis had told me that it's very delicate getting up there. Is that what you found?
Yeah, there was a series of chimneys and traverses and crawls, and we found some neat. Dan spotted some neat biology up there. There was a pool that we had to go over top of, and I wish I would have sent you the picture of it, Emily, so I could have thrown it up here. I sent that picture to Dr. Diana Northup. She hasn't seen my message yet. I don't know how often she checks her Facebook messaging system, but maybe I'll send it to her some other means. It was a neat troglodytic aquatic creature, about almost a centimeter long. So I'm gonna try to get that identified. Yeah, it was a great day.
Awesome. Yeah, that gypsum block is cool.
Yeah.
Was the light corroded, Dave?
Oh yes. I am hoping that another trip goes, because we certainly didn't get all the corrosion out. There's a little pile of corrosion from the light left behind. But we were able to lower the light down and leave very little behind, just a little pile of corrosion.
Cool.
Oh, I can't see that very well. Okay, awesome. So we went over, Angelina and Colin have been doing a lot of deployment of radon monitors while the park has been closed, and then Dan Pollock and Mark and Diane Juke took a photography trip way up the hill into Lake Cave, and of course that is a really beautiful cave to spend time in if you want to deal with the hike, which is a bit much for me. So I've got a little bit of caving news to go over. The Southwestern region, of course, just came out with their their every other month newsletter. So if you didn't get your newsletter, you should go join the Southwest region. The link is in the agenda that went out to your emails, and it's only $10 for an annual membership. And I had a lot of fun reading the newsletter. It actually featured Angelina and Ellen, and that trip that Angelina talked about with Mike Manser and the repairs in Cottonwood. So fun newsletter to read. And so if you haven't joined, go join the Southwestern region, $10. You know, you're not buying coffee right now, so perfect. Of course, the Lechegi Cave celebration, the 150-mile celebration, is postponed. There is no date for when it's going to happen. We're not really sure when the park's going to reopen and what's going on, so just stay tuned. I did see Aaron Lynch in on the call. Did you have anything you wanted to add to this, Aaron? If you're there. Okay. Stay posted.
Yeah, sorry, yeah, we have, they're still in discussions with Washington Ranch and want to see when things start to open up, but provisionally in the fall, unless there's a second wave of coronavirus, in which case maybe this time next year.
Okay, awesome, thank you. Yeah, just stay tuned for now. Same thing with the Southwestern regionals, the spring regional, of course, postponed for now as well. Just stay posted. As far as I've heard, I know Angelina and Gabe are both signed up to attend this. I think there's still NCRC going on in New York in June, as far as you know, Angelina, yes?
I spoke with Greg Moore, the site coordinator. Probably spoke to him a week or two ago, and so far it is on. However, they are going to gather and make a final decision May 1st. He didn't disclose this, but I think he's kind of leaning towards it's going to be canceled. But again, for right now, it's on May 1st. A final decision will come from the NCRC to see if it's on or not.
Okay, thank you. In the meantime, you can sit on your couch, and while you're watching TV, you can practice your knots. The NSS convention is still on in Elkins, West Virginia in July. Pre-registration is open until the end of May. As with anything, just stay posted, stay in touch with the community, and see how things go, because I don't think anyone really knows at this time. And then I just compiled a few things to read and watch if you're just sitting at home and need something to do, feeling a little restless. Dr. Hazel Barton presented a really awesome introduction to viruses and the coronavirus. And the webinar that she presented was recorded and it's posted on caves.org. So whether you're a member or not, you can go to this link. It's in the agenda that I sent out to y'all, and you can listen to it. It's a little over an hour, really informational, and I learned a lot from just listening to that little webinar about the coronavirus. If you are a member of the NSS, the Journal of Cave and Karst Studies came out in March, so you can go read some articles in there. And then Derek Bristol and the NSS Board of Governors has produced a 4-part video series, mostly aimed at new cavers, but you know, we can all brush up on our skills while we're sitting around home. So it's a 4-part video series. The first one was just an overview of caving, and he is releasing one every Thursday during the month of April. So I put the link in here for, you can just go to caves.org. It's right there on their homepage. Or if you follow Derek Bristol's YouTube channel, he's been posting them as well. So just some fun things you can do if you're feeling like you're not underground and you're getting a little antsy. You can pretend you're underground from your living room. Does anyone else have any caving news they'd like to share at this time?
Yeah, this is George. One of the things that that you can do, at least I'm doing it, is I can still find new caves. I can still go cave hunting without even leaving the house. Even though I've been living in New Mexico now for over 13 years, I'm still the data manager for 3 Texas counties around San Antonio. And some people just sent me some leads about, hey, there's this neighborhood, there was a cave there, you know, when it was being developed. And they gave me enough information that with Google Earth and some of the latest high resolution imagery, I could see right through the trees, right down to a big cave entrance, 6 meters long, 4 meters wide. So I've, you know, pinged the local Growler members there to go check it out when they can get out. So there's stuff, you know, to still do, and do some cave hunting locally, or more remotely. Look at the high-rise imagery that Penny was talking about. But yeah, there's possibilities out there.
Thank you, George. Dan Pollock is currently watching my dog, so she doesn't bark during our Zoom meeting. But he wants to mention that Cave Week is May 3rd through 9th. So if you're following any cave park on social media, stay tuned in. You'll probably see some posts about a variety of caves around the nation. It's the National Park Service's Cave Week, May 3rd through 9th. So you can virtually see what's going on around the nation in caves. Anything else floating around out there? Okay. All right. So treasure reports. I'm not sure. Phyllis, are you one of the call-ins over there? Okay. Well, we have money. Secretary report. Angelina, do you want to share a little bit with us?
Yeah, definitely. So I can actually quickly go back to February, since our meeting last month was canceled, of course, due to everything going on. Let me just quickly go back to February's notes. I was actually not in attendance. Thank you, Andy, who was alongside Kelsey, for taking notes for me. And so February's meeting, we had a great presentation on Missouri Caves and Karst by Mr. Michael Moffitt. I'm not sure if Michael's on, but thanks, Michael, for that. Some news that is still relevant for us now. Dave Jackson and Cave Sim, with Cave Sim, sent us a Christmas card and a thank you to the Pecos Valley Grotto. We go ahead and we donate to them, I believe, every year. So he sent a thank you and a Christmas card out to us. Let's see what else is still relevant. A lot of the stuff was postponed, of course, last month. I think we're going to go over this stuff later here, so I'm going to go through that. Back in February, we had trip reports over to Karstner Caverns in Arizona. Apparently, there was a trip out to Lost Cave with some new cavers, and it looks like we had some of those restoration trips to Cottonwood Cave, a couple rec trips to Black, 2 trips to Hidden, and a trip to the New Mexico room. And at least back in February, before everything kind of happens, if you will, Phyllis expressed interest in going to the Guadalupe room. So I don't know if Phyllis is on, but I'd be happy to take you in there, Phyllis, once things get back to normal. I'm not sure if you're on the call or not. I can just email her, of course. And of course, maybe the biggest thing that happened in February is we elected our new officers for the year. So we elected Emily Roach as chair, of course. Dave Broombaugh is our vice chair. I was elected as secretary, and Phyllis was re-elected as treasurer. So for March, we had our meeting canceled. What we had in lieu was the agenda and the slideshow distributed via email. Thanks, Emily, for doing that. I thought it was great. No presentation, of course. And then all the caving news came out. So basically, like we just mentioned, regional postponed, the Lech 150-mile celebration postponed, High Guads Restoration Project for that first weekend of April was canceled by Jen Foote. And there was news of the Gone Caving, a card game, that came out. And then I guess new business we'll go over later on. We have the banquet planning to do with White Sands Grotto for the region's winter tech here in Carlsbad. We need to discuss trails we adopted in the Lincoln National Forest, which Ranger Kelsey will go over in a little bit. And then pick a date for work on Sea Hill. I believe Ken Harrington has the supplies for that. And we had talked about maintaining our website, having an additional webmaster, ordering a sandwich board and plugin for community events such as Cavern Fest. And finally, we had trip reports in March out to Sentinel Cave. I know Hunter and Dwayne have talked a lot about that. Looks like it was a real fun trip. We also had recreational trips to Helen's Lake, Deep Cave, Slaughter Canyon, and we had at least one rope practice out at Cottonwood Recreation, the day use area on BLM land.
Awesome, thank you. Lots of caving. I realized I did skip trip reports in the future. Of course, the NSS has suggested a bit of a stand down from caving while we wait and see how things are going to slowly reopen. So like Angelina mentioned, she's a trip leader for the Guadalupe room. So as things slowly start to reopen, we can start to plan some trips again. I'd love to take a group back into Lost Cave. I love the history in there. We have some new trip leaders coming up for the historic route on the Old Main Corridor in Carlsbad Caverns. So, you know, make a list of where you want to go, and we'll try to plan some fun stuff when we can cave again. So for old business, in February, we did adopt 2 trails in the Lincoln National Forest. We adopted the trail inside of Cottonwood Cave, and then we also adopted trail T217, which is pretty beautiful. So let me figure out how to stop my share here, and I'm gonna hand the board over to Forest Ranger Kelsey Smith, who we adopted those trails from. So let me see how oh, there's we go. All right, so Kelsey, why don't you take over and tell us a little bit about what we signed up for?
Okay. Hi, everyone. So for those